Hi, this is Quantum Mechanics by David J. Griffith. The first chapter as wave function. The first topic of the chapter is Schrodinger equation. Schrodinger equation plays a crucial role in quantum mechanics, analogous to the second law, Newton's second law of motion in classical mechanics. Let we have a case, a particle of mass m which is constrained only to the x-axis or which is constrained only to the x direction, which is subjected to a force. Now, the job of classical mechanics is to find the position of this particle. If we can find the position of this particle, we can also find the velocity of this particle, because velocity is equal to dx by dt, change in position divided by change in time. Now, if we can find the velocity, we can also find the momentum, we can also find the kinetic energy, and we can also find other dynamical variables of interest. Now, quantum mechanics approach is quite different from classical mechanics. Quantum mechanics is looking for the wave function of this particle. The wave function is represented by psi, which can be found from Schrodinger equation. Schrodinger equation is equal to I h cut curly psi by curly t is equal to minus h cut square divided by 2m curly square psi by curly x square plus v psi. This is Schrodinger equation. We can find psi, a wave function, from this equation. So here the I mean iota, which is equal to square root minus 1, and h cut is equal to Planck's constant divided by 2 pi, which is equal to 1.054 cross 10 raised to power minus 34 joule second. Now, please note a point that in the whole book we will deal only with the non-relativistic cases, mean with the speed of the particle as very less than the speed of the light. So we will deal only with the non-relativistic cases. As you know that Schrodinger equation plays a crucial role, logically analogous to the Newton's second law in classical mechanics. So Schrodinger equation is analogous to Newton's second law, but Newton's second law can only deal with the classical mechanics, and Schrodinger equation can deal with the quantum mechanics. Now, the Schrodinger equation can determine psi x of t for all future times. As you know that Newton's second law can also find position for all future time. So Schrodinger equation can also find wave function for all future time for suitable condition. So this is our first topic, that what is the dealing of Schrodinger equation, or what is the dealing of quantum mechanics. Quantum mechanics deals only with wave function. Classical mechanics is dealing with the position directly, but classical mechanics is only dealing with the Schrodinger equation or wave function.